Hi, Algebra 1. In this video, I'm going to be going over the Week 8 practice, which is a review to help you prepare for the Quarter 3 progress check. So some of you maybe have already done the review and you're watching the video to compare your answers and check your work. Some of you maybe haven't done the review at all and you're going to be doing it and showing your work along with me as we go. So either way is completely fine, whatever works best for you. So for our first problem, it asks us to state if each table represents a linear, quadratic, or exponential function, and we need to show our work. So first, let's remember how we can tell if a table is linear, quadratic, or exponential. It's been a little bit since we looked at tables, so let me remind you. We learned a little while ago that we can tell a table is linear if the y values are adding or subtracting by a constant number. So we're always looking at the y values to figure out what pattern we have. We also learned a little while ago that for exponential functions, we can tell a table is exponential if it is multiplying or dividing by a constant number every time in the y values. And then quadratic is a little bit different. That's the most recent one we've learned about. Quadratic is, we can tell it's quadratic if the y values have a constant second difference. Okay. And you might not really remember what that looks like, but you'll see when we get to our quadratic table. So the way I do this, when I'm trying to figure out what kind of table I have, I use process of elimination. So I go through each type and see if it works, and then I move on to the next type. So I always start by figuring out if it's linear, then I'll move on to exponential, and then if it's not linear or exponential, then I know it has to be quadratic and I can show that it's quadratic. So I always go in that order: linear, then exponential, then quadratic. So for our first table, we have the y values 1, 3, 9, 27, 81. So like I said, I'm going to start by seeing if it's linear. So linear means it's adding or subtracting by the same number every time. Since my numbers are getting bigger with the y values, I know that if it's linear, it would have to be adding. So I'm going to start by trying adding. So that means I need to figure out what do I have to add to 1 to get 3. If this is difficult for you to figure out, you can always use a calculator, take the bottom number and subtract the number above it, and that will tell you what you're adding by. So we're adding by 2 here. So I'm going to write plus 2. Then I'm going to try and figure out what I have to add to 3 to get 9. I want to see if it's also 2. If it's 2, then I do have a pattern. If it's a different number, then I don't. So again, if you're not sure, you can do 9 minus 3. That tells us it's adding by 6. So right away, we can see that this cannot be a linear table because it's not adding by the same number every time. So it's not linear. We've eliminated that option. Now we'll try and see if it's exponential. If it's exponential, that means it's multiplying or dividing by the same number every time. Once again, since my y values are getting bigger, that would tell me it has to be multiplying. If it was dividing, the numbers would be getting smaller. So I'm going to see what do I have to multiply 1 by to get 3. Again, if you need a calculator, what you do is you take the number below and divide by the number above it. So like before we would use subtraction, now we use dividing. So if I do that, that tells me it's multiplying by 3. So 1 times 3 gives me 3. Now I want to see if I will get the same thing when I do from 3 to 9. So again, you can do 9 divided by 3, the number below divided by the number above. That gives me 3 again. So that means it is multiplying by 3. Okay. So it looks like we're getting a pattern. Now we want to make sure it keeps working though. So once I see it twice, I usually just start saying, let me do 9 times 3 in the calculator and see if I get 27. So 9 times 3, yep, that gives me 27. And then I want to check that 27 times 3 gives me 81. And it does. So this is an exponential pattern because it's multiplying by 3 and the y values every time. So exponential. All right, we got one of the tables done. Let's go on to the next one. So again, I'm going to start all over with my process. My y values are 3, 5, 7, 9, 11. So I'm going to start with seeing if it's linear. If it were linear, it would be adding or subtracting. And once again, my y values are getting bigger, so I'm going to try adding. So I want to figure out 3 plus what gives me 5. Again, if you're not sure, I showed you the trick in the calculator. Subtract the number below by the number above, but I'm not going to keep showing it. So I would have to add 2 to 3 to get 5. And then I'm thinking, what do I have to add to 5 to get 7? I have to add 2 to 5 to get 7. So it looks like I'm starting to get a pattern. 7 plus 2, that does give me 9. 9 plus 2, that does give me 11. So right away, we found out it's linear. We don't have to check exponential or quadratic because we've already found it's a linear pattern because it's adding by 2 every time. So this is a linear table. Now we're on to our last one. I have a feeling it might be quadratic since we haven't seen one yet, but we got to check. So my y values are 5, 9, 15, 23, 33. I start again. They're getting bigger. So once again, I'm going to try adding first. So 5 plus what gives me 9? That would be plus 4. Use your calculator trick if you need it. 9 plus what gives me 15? That would be 9 plus 6. Right away, I'm not getting a pattern. So it can't be linear. All right, now we can try exponential. So I'd be thinking 5 times what gives me 9? This one is a little hard. I'm starting to think it's not exponential because it should be something I know in my head, but I can do 9 divided by 5. That gives me 1.8. So if it were exponential, it'd be multiplying by 1.8 here. Let's see if I get the same thing when I do from 9 to 15. So I do 15 divided by 9. That's giving me 1.6. Okay, so it's definitely not multiplying by the same thing each time. It's definitely not exponential. We had a feeling because it didn't look to be a pattern, but we definitely know it's not exponential. Since it's not linear or exponential, it has to be quadratic. The way we show it's quadratic is by showing that the y values have a constant second difference. So that means we're actually going to find the first differences just like we do with the linear function. And even though they're different, then we're going to find the differences between those, and that number should be the same every time. So we already said to get from 5 to 9, we add 4. To get from 9 to 15, we add 6. Now we're going to keep going. 15 to 23, we have to add 8. Again, if you don't know that, you do 23 minus 15 in a calculator. And then 23 to 33, we have to add 10. Now, to find the second differences, I find the differences between these, 4, 6, 8, and 10. So to get from 4 to 6, I add 2. To get from 6 to 8, I add 2 again. 8 to 10, add 2. Okay, that is our constant second difference. Since we're getting the same number of 2 every single time, that shows that it is a quadratic function. So we were pretty sure because that was our last options, but we were able to confirm it by finding the constant second difference. And that's how we show our work as well. All right. Now, the rest of this is really going to all be about quadratic functions because that is the unit we're learning about. But you did have to know how to identify that a table is quadratic. So let's go on to problem 2. So problem 2 says convert the following quadratic function from factored form to standard form. Okay, so remember, we can tell it's in factored form because it's got the parentheses, it's got an x in each parentheses, and then standard form is when we multiply everything together and we get our x squared term, our x term, and our number by itself. There are kind of two options for how you might have learned how to do this. We used the FOIL method, and then we also used a box method that some people liked better, so I'm going to show it both ways at the same time. So if you don't remember, we have our FOIL method. FOIL stands for first, outer, inner, and last. And both of these methods are just ways to help us remember. Since we're multiplying x plus 2 times x minus 6, we have to make sure we multiply every possible combination of each factor together in order to get our answer. And this helps us make sure we don't forget anything. The box is another way to help yourself not forget anything. So when we do the box method, I make a box with 4 squares, and then I put my factors along the edges. It could be flipped from what I have, but I'm going to put x plus 2 on top and x minus 6 on the bottom. So that was the other way we did it. So use whatever way works best for you. So based on FOIL, the first tells us to multiply the first terms in each set of parentheses together. So x times x, let me get my y equals, can't forget that. X times x, we should know by now that gives us x to the power of 2, or x squared. And if you're doing it in the box, that's where we do the top left box. X times x gives us x squared. Then we do the outer terms. So x times negative 6. Whenever I'm multiplying a variable times a number, I just remember to put the number in front of the variable. Just smush them together is what I say. So negative 6x If you're doing it in the box, that's the bottom left box. X times negative 6 gives you negative 6x. The inner terms, that's 2 times x, so plus 2x. That would be the top right box. 2 times x gives us 2x. And then my last terms, that's 2 times negative 6. 2 times negative 6 gives me a negative 12. If you need to do that in a calculator so you don't mess up the negative, that's fine. And that's our bottom right box here. Now, our last step is to combine like terms. If you do it in the box, you do have to take an extra step here to write it all out in order. I just go left to right on the top and then left to right with the bottom row to write it in order. Now, I need to combine my middle terms. It's always my middle terms that can be combined, my 2x terms. They're like terms because they both have 1x. So I carry down the x squared, and then I think negative 6x plus 2x. That's like doing negative 6 plus 2 in a calculator, and I get negative 4x, and then minus 12 I carry down. And that's it. That's my standard form. I have my x squared term, my x term, and my constant term at the end. So that's how I know it's in standard form. Now, my next problem is to convert this quadratic function from standard form to factored form. So we're going in the opposite direction. I have my x squared term, my x term, and my constant, and I want to convert it to look like the factored form. So to convert to factored form, we're going to need our multiply and add table. We have to factor to convert to factored form. Not surprising, right? So I always start by making my multiply and add table. And this is something oftentimes I would give you this on your homework or on your classwork, but you know, when you're doing a progress check or something like that, they're not going to give you that. So you need to practice making your own table. So we have to multiply to the number at the end, the constant value at the end of the equation. So we're multiplying to negative 6, and then we're always adding up to the number in the middle with x, so adding up to 5, positive 5. So my first step is I always list all my factors of what I'm multiplying to. If it's negative, I always start by ignoring the negative, and then I figure out the signs later. So I'm just trying to list all the factors of 6. Our first factor of any number is 1 times that number, so 1 times 6. Next, I would try 2. If you don't know, you can take the number you're trying to multiply to, divide by 2, and see if you get a whole number. You get 3. So that means 2 times 3 is our next factor pair. The next one I would try is 3. But 3 is already in my list, so that means I'm done. Those are all my possible factors. So now I have to figure out which ones add up to 5. But first I have to think about my signs. We can have 2 positives, which multiply to a positive. I can have 1 positive and 1 negative, which multiplies to a negative. And I can have 2 negatives, which multiply to a positive. Since I'm trying to multiply to a negative, my only option I could choose is to have 1 positive and 1 negative number. And then I need to think about the fact that I'm adding to a positive. If I'm adding to a positive, that means the smaller number should be negative. So I'm going to make the 1 negative and the 2 negative. Now I can pick which of these adds up to 5. Well, negative 1 plus 6, if you're not sure, you do that in a calculator. Negative 1 plus 6, that gives me 5. That's what I'm looking for. I can double check negative 2 plus 3 doesn't give me 5. Let's check negative 2 plus 3. That gives me 1. So my answer has to be the negative 1 plus 6. So now I just have to write my factored form. Y equals, I have one factor, that's x minus 1, and then another factor, that's x plus 6, because those are the two numbers we chose. All right. Okay, on to problem 4. Problem 4 says, use the equation in factored form and its graph below to answer the questions. Okay, so we have the equation y equals x minus 3 times x minus 9, and we have the graph. A asks us, what are the x-intercepts of the function? Be sure to write your answers in xy coordinate form. Well, I always know I can find my x-intercepts by looking at my graph, looking at where my graph touches the x-axis, which looks to be here and here. So I see that that's at positive 3 and at positive 9. So to write it in xy coordinate form, we always remember that the y value is 0 along the x-axis. So my x-intercepts are 3, 0, and 9, 0. B says, in general, how can you find the x-intercepts by looking at the quadratic equation in factored form? Okay, so now I'm looking at my equation up here, x minus 3, x minus 9. And I want to make sure I know what if I didn't have the graph? How would I find my x-intercepts from the equation? Well, I can see, if I forgot, I see a -3 and a -9 in my factors. And that seems similar to the fact that my x-intercepts are +3 and +9. It's just that the signs are switched. So that's something we did learn, but in case you forgot, this kind of helps you remember. So I can always find the x-intercepts. So the x-intercepts are the numbers in factored form the two numbers in factored form, but we have to make sure we remember the signs are flipped. Or we could say opposite, maybe is a better word. The signs are opposite. So when I look at my factored form, I see x minus a number times x minus a number. I end up with 2 positive x-intercepts. So we're going to use that to answer the next question, which says, what are the x-intercepts of the following equation? This time they didn't give us the graph. We have to be able to do it from the equation. So if I look at my equation, I have +2 and +8 in my factors. So that tells me I have 2 positives in my factors. That means my x-intercepts will have the opposite sign, so they're both going to be negative. So -2, 0, and -8, 0. And by now we should definitely be remembering the y value of any x-intercept is always 0. You want to make sure you're putting these things in coordinate form. All right, problem 6 says, what is the vertex of the following quadratic function? Be sure to write your answer in xy coordinate form. And this is given to us in factored form, and we've learned how you can find the vertex from factored form. It's the most recent thing we've learned, so it might be a little bit more new. So I'll try and explain it very clearly as we go. So the first step, if I'm trying to find my vertex from my factored form equation, is I do need to find my x-intercepts first. And we just talked about how to do that. I can find my x-intercepts from factored form by looking at the +6 and the -2 and flipping the signs. So my +6 tells me I have an x-intercept at -6, 0, and then my -2 tells me I have an x-intercept at 2, 0. All right, now my next step for finding the vertex is we learned in class that the vertex is always halfway between the x-intercepts. And if you don't know what the vertex is, that's like the minimum or the maximum. It just depends, but we just refer to that point, that tip of the graph, as the vertex. So I want to find the halfway point between -6 and 2. So that's going to give us the x value for our vertex, and then I'll show you what to do with it after that. So if you had a graph, it'd be pretty easy to find the halfway point just by looking, but when we don't have a graph, there's a really nice trick, which is to add the two numbers together and then divide them by 2 to find the halfway number. So -6 + 2, and then divide it by 2, that's going to give us our halfway point. So if I add -6 + 2, that gives me -4. Again, you can always put that in a calculator. And then -4 divided by 2 gives me -2. So that means the vertex is going to be at the x value of -2. Now it says I need the x and the y value. So to find the y value of the vertex, I take that number -2 that I just got and I plug it back into my original equation. So I'm going to write y equals 3 parentheses. Instead of x, I'm replacing it with the -2 I just found in both spots. So just to be super clear, we found the x value is -2, and now I'm plugging it in to both of my factors into my equation, and I'm going to evaluate this. So you could type this all into the Desmos calculator, like all of it just as it is. If you type it perfectly into the Desmos calculator, you'll get it all in one step, but I'm going to show you how to do it in 2 steps where you simplify. So first I want to do what's -2 + 6. That gives me +4. And then -2 - 2, that gives me -4. You could have done those individually in the calculator if you needed to. And then I just need to do 3 times 4 times -4. That we would definitely, we could maybe do it without a calculator, but I'm going to use a calculator. 3 times 4 times -4 gives me -48. So that's my y value of the vertex. And then I'm just going to put it into xy form. So I put the x value first, -2, and the y value is -48. Just going to highlight that so we can see where everything came from. All right. Again, that's like the most recent thing we've learned, so if that felt new to you, that's okay. All right, on to the second page. Second page says, problem 7. Solve for x. Hint, remember to make sure the equation is set equal to 0 before solving. Your answer should be whole numbers. Okay, before I even start solving, I'm going to follow that hint and make sure my equation is set equal to 0. Right now it's set equal to 11, so I need to move the 11. It's positive, so I need to subtract it. And I'm going to subtract it from the 2 because that's the other constant. Like, that's the number that doesn't have an x with it, so that's what's going to get subtracted from. So I carry down the x squared and the minus 8x. 2 minus 11, that gives me negative 9. Do it in a calculator if you need to. Now the 11 minus 11 goes away and I have a 0, which is exactly what I wanted. Now, we've learned 2 different ways to solve. We've learned factoring and quadratic formula. I think that looking at this equation, it looks like something I could factor, especially because there's not a number in front of x squared. We never learned how to factor with a number in front of x squared. So when I don't see a number in front of x squared and the numbers are kind of small like this, like -8, -9, I can definitely come up with, I can try and make a multiply and add chart and see if I can factor it. If I make a multiply and add chart and I can't come up with any combination, then I can do quadratic formula. So I'm going to make my multiply and add chart, see if it lets us factor it. There's also kind of a nice hint here saying the answers should be whole numbers. If the answers are whole numbers, then you can definitely factor it. On the flip side, though, you can solve any quadratic equation by quadratic formula. You could solve this by quadratic formula and still get the right answers if you don't make any mistakes. So if you're on the progress check and you have to solve quadratic and you're like not a good you don't really like factoring, but you're better at quadratic formula, then you could solve any equation by quadratic formula. I just think this looks like something I can factor, so I'm going to factor it. If you use quadratic formula, though, you should still get the same answers when you put them in the calculator. So I need to multiply to the number at the end by itself, the -9, not the 0, the number on the left side by itself. And then I need to add to -8. That's the number in the middle with x. So I start by listing my factors of 9. I ignore the negative for now. I'm going to come back to that. 1 times 9, that's always the easiest first factor pair. Then you might try 2. That would be the next one to try. If you don't know whether 2 goes into 9, you do 9 divided by 2. I get a decimal. So it doesn't go in. Then I can try 3. 3 does go in. I get 3 times 3. I could go on and try 4, 5, 6, but since it's already coming back around to 3, that means there aren't any more factors. But if you needed to try those to check, you could. Now we figure out our signs. Since it's multiplying to a negative, I'm going to remind us positive times positive is a positive. Positive times a negative is a negative. Negative times a negative is a positive. I'm multiplying to a negative, so I need to have one positive and one negative. And since I'm adding to a negative, the bigger number should be negative. So whatever I'm adding to, the sign of that number is what the bigger number should be. So that means the 9 would be negative, and oh, we get a little tricky here because they're both the same, but we will see. Now, I need to see which one adds up to -8. So 1 plus -9, you can check it in the calculator. 1 plus -9, that gives you -8. And then that's exactly what we wanted. If you checked 3 plus -3, you would get 0. They cancel out. So it has to be 1 plus -9, and then I'm just going to write it in the factored form. So x plus 1, x minus 9 equals 0. Now we still have to do our solving step, so we set each factor equal to 0 and solve. So I set x plus 1 equal to 0 and x minus 9 equal to 0. And then to solve these, some of you just remember flip the signs. I actually am going to do the step to solve. So if I subtract 1 on both sides, I get x equals -1. If I add 9 on both sides, I get x equals +9. And it asks us specifically for the negative solution. So -1, that's the negative solution I got. And these are the two solutions. Okay. If it asks you for just one of the solutions, like the negative or the positive solution, you still have to do all the work and you still have to get both. It's just asking us to put in the blank that specific solution. All right, problem 8, the following quadratic equation cannot be solved by factoring. Why can't it be solved by factoring? Well, if I'm not sure why, I always try and say, what happens? So if I were to make a multiply and add chart, I'd be multiplying to -9 and adding to 5. I already did my factors of 9 over there. 1 times 9, 3 times 3. it's adding to a negative, and sorry, it's adding to a positive, and multiplying to a negative. So my bigger numbers would be positive, my smaller ones would be negative. Negative 1 plus 9, that would give me 8. Negative 3 plus 3, that would give me 0. So neither of those are 5. So there are no two numbers that multiply to negative 9 and add to 5. And I told you this could happen, like even though it looks like something we should be able to factor because it's like small numbers, there's nothing in front of x squared. We can try. If you get stuck, then there are no two numbers that multiply to negative 9 and add to 5. So what method can be used to solve? We can use, we just talked about this, the quadratic formula. If we can't factor it, we can use the quadratic formula. So that's what we're going to use in the next one. And this one, it doesn't tell you to use quadratic formula, but when I look at the problem, it says solve for x, 3x squared plus 7x minus 2 equals 0. When I see this 3 in front, we did not learn how to factor like that, really. So once I see that, I know I have to use quadratic formula, just based on what we've learned in this class so far. It also gives us the hint that your answer shouldn't be whole numbers, so we know we can't factor if the answers are like decimals. So we're going to use quadratic formula. It's already set equal to 0. How nice. We just have to identify a, b, and c. So a is the number in front of x squared. A equals 3. B is the number in front of x. B equals 7. C is the number by itself, the constant. I always remember C for constant. C equals negative 2. So A is 3, B is 7, C is negative 2. Now I am going to use my quadratic formula. It's already over here. You'll always be able to have it on your formula sheet. It's not going to be a secret. You don't have to memorize it. But what I do is I always write down the quadratic formula as I see it. But whenever I see a variable, I put blank parentheses, and then I'm going to fill in the parentheses. So I have x equals negative. I see b, so I put parentheses for the b, plus or minus square root of b squared. So parentheses squared minus 4ac. So parentheses for the a, parentheses for the c. Not my best square root. Not my best looking square root. And then all over 2a. So I put parentheses for the a. Now I just got to fill everything in. It says negative b, so a 7 goes here for the b, plus or minus the square root of b squared, so 7 goes here as well, minus 4ac. So a is 3, so 3 goes here, and then c is negative 2. So negative 2 goes here. And then in my denominator, I have 2a, so 2 times 3. So just fill it in as you see it. And then we got to simplify it into 3 parts. So the part in front of the plus or minus sign, that's just negative 7. There's only one negative sign, so I just keep the negative with the 7. If you see 2 negative signs, then it becomes a positive. Square root, I need to figure out what everything under the square root is. So I'm going to have to put 7 squared minus 4, parentheses 3, parentheses negative 2. I always recommend using a good calculator for this. Oh, didn't mean to do that. I'm trying to pull it up. I have to be slower. Here we go. All right. So I'm going to put exactly what I see under the square root in here. So parentheses, although I can't see the parentheses when I do it like this. This happened to me last time. Oh, there it is. Okay. Parentheses, 7, parentheses, squared, minus 4, parentheses, 3, parentheses, negative 2. That gives me 73. I don't think I need the calculator anymore. So I got 73, and then 2 times 3, that gives me 6. My lines are not very pretty today. All right, that's it. Oh, well, then I have to write it both ways because I have a plus sign and a minus sign. So my two solutions are x equals 7 plus the square root of 73 over 6, and then x equals 7 minus the square root of 73 over 6. Those are my two solutions. All right, problem 10. We're looking at a pattern, and honestly, the only type of patterns we've looked at in this unit are quadratic patterns, so we can kind of assume it's going to be quadratic. We also have a table already made for us, which is nice. It wants us to figure out how many squares there would be in figure 7. So we could start this by thinking about our different tables. Like we could start by just looking at the table. If some people might be able to look at the pattern and see what's happening with the squares, but if you can't, which a lot of people can't, just look at the table first. So I'm going to do it with the table, but then I'll show you how you could see it with the squares. So we could check first that it's not linear or exponential. So if I were to do that, I would check what's 5 to go from 5 to 8. It's plus 3 to go from 8 to 13. It's plus 5, so it's not linear. And then I could try exponential. 5 times what gives me 8? I'm already stumped with that. Like I could do it in a calculator. You're going to get 8 divided by 5. Ooh. 8 divided by 5. It's a decimal. So it's definitely not exponential or linear. That means it's quadratic, which I could have predicted for you because we've mainly just been learning about quadratics. Now we know quadratics have a constant second difference, so let's find that. So 5 plus 3 gives us 8. We have to find the first differences first. 8 plus 5 gives us 13. 3 plus 7 gives us 20. So the first question is asking us how many figures would there be in figure 7. So I could extend the table. I'm going to ignore that one, that row with the n for now. 5, 6, 7. I could figure it out like this. So I can see that what I'm adding by is increasing by 2 every time. So that means my next one would be adding by 9 to get to figure 5. So 20 plus 9 gives me 29. Then I would have to add, so if I added by 9 before, now I'm adding by 11. I just keep increasing what I'm adding by 2. Adding by 11 would give me 30. And then if I add by 13, that'll get me to figure 7. That gives me 43. So there would be 43 squares in figure 7. I think that's the easiest way to find how many squares there would be by looking at the table. If you know it's quadratic, you'd see that it's adding by a number that's increasing by 2. Some people think of it as adding by every odd number and do it that way. Now, now we're going to do the equation for figure n. So we talked about how to make quadratic equations from a table. We always want to make an x squared column. In this case, we're just using a different variable. So I'm going to make an n squared column in my table to help me figure out what the equation is. So n squared, that means I'm taking the figure number and multiplying it by itself. So 1 times 1 gives me 1, 2 times 2 gives me 4, 3 times 3 gives me 9, 4 times 4 gives me 16. I'm just going to do those 4. I don't need to do the whole thing. So then I always say, now that I have my n squareds, I'm trying to figure out how to get from my n squared to my actual number of squares. So how to get from 1 to 5, I would have to add 4. To get from 4 to 8, I have to add 4. To get from 9 to 13, I have to add 4. And to get 16 to 20, I'm adding 4. So every time I'm taking n, I'm squaring it, and then I'm adding 4. So that's my equation, n squared plus 4. Okay, so you can do all of that just by using the table. You don't even really have to look at the pattern. Now, some people who are more visual, maybe if you saw in the pattern, if you know this is quadratic, which we do, you can expect anything like this on your progress check is going to be quadratic, because that's what we've been learning about. You can find the n squared. So like figure 1 starts with 1 square. Figure 2 starts with 4 squares because it's 2 times 2. If you find the perfect squares in each figure, so 3 is 3 by 3, think of it as a 3 by 3 square. My highlighter is not working very well. And then figure 4 would be a 4 by 4 square. So if you can go into each figure and find the perfect squares, so 1 by 1, 2 by 2, 3 by 3, 4 by 4, see what else is going on. I see that every single, maybe I'll make this to match my table, make this red. Yeah, and then every single one has an extra 4 squares. So you can, even though they're all in kind of different places. So that's another way to do it. If you're more of a visual person, find the perfect square and then see how many extra squares there are. And if, obviously you would have to like draw this on your paper. If you're on the progress check, it's all on the screen. So you'd have to take the time to draw it. So the table might be easier, but that's another option. Okay, last one. This one should be quick. This is the most recent thing we've learned. Problem 11. Raina threw a basketball off the top of a building. The path of the ball is represented by h of t equals negative 16t squared plus 74t plus 30, where the height h in feet is a function of time, t in seconds. First question, what does the negative 16t squared represent? We've talked about this a lot. No matter what object we're talking about, that negative 16t squared represents gravity, the force of gravity, which is what causes the ball to eventually come back down to the ground. That's why it's the only negative term. I always think of it as the only negative term in the equation. That's my gravity. What does 74t represent? Okay, that's my middle term. We learned in class that the number with t by itself is the initial speed. So the initial speed of the ball, which would be 74 feet per second, because those are our units. So the initial speed is always that middle term, and then the 30, we know that is that number by itself at the end is the initial height of the ball, which is 30 feet because it's off the top of a building. You can also see the initial height in the graph as the y-intercept, but you don't need the graph because you can just look at the equation. And then at what time does the ball hit the ground? This I need to definitely look at my graph for. So the ball hits the ground, that means the height is 0. So I'm looking for the x-intercept over here. When the ball hits the ground, it looks like it's at 5. So the ball hits the ground after 5 seconds. And then what is the maximum height of the ball? I'm going to go to where is the highest point I'm estimating. So the highest point is around here, and I'm going to estimate. So I'm going to look over at my height. It's asking me for what the actual height is, which is on the y-axis. It looks like it's between 110 and 120, about halfway between. So about halfway between would be 115 feet. If you said 114, 116, those are all good too, because it's an estimate, as long as it's close. All right, that's everything you need to review for the progress check. Hopefully this helped you, and good luck studying, and good luck on your test.